Think you know everything about space? Think again. Space is vast, mysterious, and often misunderstood. From black holes to the size of the universe, common myths about space abound. In this series, we're embarking on a cosmic quest to debunk these space myths and reveal the astonishing reality behind them. Let's start with a big one: black holes. These enigmatic objects have fascinated scientists and the public alike for decades. Many people think black holes are like giant cosmic vacuum cleaners, sucking up everything around them, devouring anything that comes too close. But that's not quite true. Black holes don't actively pull in objects from a distance. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. This intense gravitational pull is due to the immense mass packed into a very small area. This extreme gravity is a result of a massive amount of matter squeezed into a tiny space, creating a point of infinite density known as a singularity. But here's the catch: black holes behave like any other object with mass. They exert gravitational force just like stars or planets. If you were to replace the sun with a black hole of the same mass, Earth wouldn't be sucked in. The gravitational pull would remain the same. Instead, it would continue orbiting the black hole just as it orbits the sun now, maintaining its regular path. The gravitational pull of a black hole only becomes extreme when you get very close to it, crossing a boundary known as the event horizon. This is the point of no return. So, while black holes are incredibly powerful objects, they're not cosmic vacuum cleaners indiscriminately sucking up everything in their vicinity. It's the extreme density and gravity within the event horizon that make black holes so fascinating and mysterious, capturing our imagination and driving scientific inquiry. Next up, is space truly cold? Well, yes and no. Space is mostly empty, which means there's no medium, like air or water, to conduct heat. But temperature in space can vary wildly depending on where you are. Temperature is a measure of how fast the particles in a substance are moving. In space, there are very few particles, which means there's nothing to bump into and transfer heat. So, if you were to place a thermometer in the vast emptiness of space, far from any stars or planets, it wouldn't register any temperature at all. However, that doesn't mean space is always cold. If you were to stand on the surface of Mercury during the day, you'd experience scorching temperatures of up to 800 degrees Fahrenheit. On the other hand, if you were to venture out into the shadow of a planet or asteroid, temperatures can plummet to hundreds of degrees below zero. So the temperature in space is all about location, location, location. You've probably seen astronauts floating around in the International Space Station or in spacecraft and thought, there's no gravity in space. But that's not actually true. Gravity exists everywhere in the universe. It's what holds the moon in orbit around Earth and keeps our solar system together. So, why do astronauts appear weightless if gravity is still at play? The answer lies in the concept of free fall. Imagine jumping out of an airplane. Before you deploy your parachute, you experience a sensation of weightlessness. You're being pulled down by Earth's gravity, but you're also falling towards the ground at the same rate as everything around you. This creates the illusion of zero gravity. Astronauts on the International Space Station are essentially in a constant state of freefall. The ISS is moving incredibly fast, around 17,500 miles per hour, which means it's constantly falling towards Earth. However, its horizontal speed is so great that it keeps missing the Earth, resulting in a continuous orbit. So, while it may appear that there's no gravity in space, it's actually quite the opposite. The sensation of weightlessness is due to the ISS and everything inside it, including the astronauts, being in free fall together. This means they are all falling towards Earth at the same rate, creating the experience of floating. So next time you see astronauts floating, remember they are not defying gravity, they are riding it. Gravity is what makes their incredible journey possible. Here's a hot one, literally. Is the sun just a giant ball of fire? Not quite. While it might look like a burning ball, the sun's energy doesn't come from fire. The sun, however, is a giant ball of plasma, a superheated state of matter where electrons are stripped from atoms, creating a sea of charged particles. The sun's immense energy output comes from a much more powerful process: nuclear fusion. Deep within the sun's core, hydrogen atoms are forced together under immense pressure. This fusion process converts hydrogen into helium, releasing an incredible amount of energy. So, while the sun may look like a giant ball of fire, it's actually a giant nuclear reactor, constantly churning out energy through the process of nuclear fusion. Next time you feel the warmth of the sun on your skin, remember that you're experiencing the power of nuclear fusion. Ever heard that the Great Wall of China is the only man-made object visible from space? It's a popular myth that has been circulating for years. It's a cool idea, but it's not true. The reality is a bit more complex and fascinating. While the Great Wall is undoubtedly an impressive feat of engineering, its visibility from space is greatly exaggerated. Many people believe it stands out like a beacon, but that's far from the truth. The misconception likely stems from the fact that the Great Wall is very long and relatively narrow. Its sheer length makes people assume it must be visible from great distances. However, from space, especially in low Earth orbit where most astronauts reside, the Great Wall is incredibly difficult to see with the naked eye. The conditions in space make it challenging to spot such a thin structure. The Great Wall is made of materials that are similar in color and texture to the surrounding landscape, making it blend in rather than stand out. This camouflage effect makes it nearly invisible from space. From hundreds of miles up, this thin line is simply too narrow to be discerned against the Earth's surface. The vastness of the Earth makes it difficult to pick out such a small feature. In fact, astronauts have reported that many man-made structures are more easily visible from space than the Great Wall. These include large cities, expansive highways, and massive bridges. Cities, highways, bridges, and even agricultural fields create distinct patterns and contrasts that are more easily discernible from orbit. Their shapes and colors stand out more prominently against the natural landscape. So, while the Great Wall of China is an impressive feat of human ingenuity, it's not the only nor the most visible man-made object from space. There are many other structures that catch the eye more easily. Our planet is adorned with countless examples of human activity that are readily visible from orbit. From sprawling urban areas to vast agricultural lands, human presence is unmistakable from space. And what about the moon's dark side? The truth is, the moon doesn't have a permanent dark side, just a far side that we don't see from Earth because it's tidally locked. The moon is tidally locked to Earth, meaning that the same side of the moon always faces us. This is because the moon's rotation period is the same as its orbital period around Earth. However, the far side of the moon is not always dark. In fact, it receives just as much sunlight as the near side over the course of a lunar cycle. It's just that we never see it directly from Earth. The term dark side is a misnomer that has persisted in popular culture. Interestingly, the far side of the moon looks quite different from the near side. So while the moon doesn't have a permanent dark side, the far side remains a place of intrigue and scientific interest. Space is full of mysteries, and it's easy to get swept up in the myths. But when we look closer, the real science is just as fascinating and intriguing. From the mind-boggling physics of black holes to the surprising truth about temperature in space, there's always something new to learn about the universe around us. Thanks for joining us on this cosmic journey. If you enjoyed learning the truth behind these space myths, make sure to subscribe for more mind-blowing science content. We'll continue to explore the universe's greatest wonders, debunk common misconceptions, and ignite your passion for the vast cosmos.